I'm Ben K from Team AB. My group members are Alexander Johnson and Paco, who's not here. And this is week 4 update. A little bit about what I'm going to talk to you today about is I'm going to go over what our background and objectives are for the first few weeks we've been working on, some experimental data that we've already collected, and the objectives that we still have yet to accomplish. What we were tasked to do is study the drying oven and do an energy study on it, along with develop an operational manual for that. And then we also have to calibrate the weighing system and the data acquisition of everything in the oven. And also we had to measure the power that's going into the oven, which has already been done. And we did that in a very rough way, so we're trying to order some new equipment so that way it can continuously be monitored, and I don't completely come in yet. And also we're supposed to take some photos and videos. So far, we've already measured the input that's going into the oven. The input is 3-phase input, and this is kind of a diagram of the 3-phase power. And the way it works is if you measure between any two of the 3 phases, you get the 240 volts that's coming in from the breaker box, and halfway in between is 120. So if you were to draw off, say, power to heat or to go to the heater, that's where we did that at. And then the bottom picture you see, it didn't turn up that well on here, but in the back is where the power comes in.
Why don't you go turn off the lights overhead and maybe that'll make it better.
It's a little better. I think you can see it on this one. The power comes in through the back here, and this is the motor in the top of the oven that spins for the fan that's uniformly distributes the heat. And the power comes into this box, which is, I'm not really sure what the purpose of the box is, but there's a heating pin on there that has come, or a cooling pin, I guess, that has come loose. And so we have to fix that today, because when we were running it last week, I think it overheated, because during the middle of a run, the oven just shut off. And so we had to throw away that data. It quit right in the middle. And then it also comes over here. It kind of got cut off, but this is a relay for the oven heater based on the LabVIEW program. It will switch on and off the resistance heater, and we calculated based on the 240 volts coming in and the measured current, we get a Q into the system from our heater at a maximum of around 7,700 watts. So we've collected some data so far. We did a couple points to find the percentage of time that the oven is on once it's reached steady state. We set the temperature to 150 at the first one, and the start point was recorded at 81 degrees Fahrenheit, and after it ran, we let it run for about 10 minutes, and it was calculated that the heater was on for a percentage of 17%. Then we did it again and increased our step to 200 degrees Fahrenheit, and it started at 150, and at that time the heater was on for 25%. So where we're going to go from here is we need to collect 2 to 4 more temperature spots to find the percentage. And once we have that data, we can make a operational curve that tells us the percentage of the Q in that is being supplied to the system based off of the temperature set point. And we'll need to know that in order to do our energy studies. We also need to run a full experiment to make sure everything's working properly. And then after that, we're going to have to make the operational manual, finish that up, just have a step-by-step guide. And then we also are going to make a memo for the juniors for them to have an experiment on the oven system, because we already have one in mind. And that is the end. Does anybody have any questions?